Hello student, good morning. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I am going to discuss battery. Last class I have discussed electrolytic cell and product of electrolysis. Today I am going to discuss batteries. What is actually battery? First you should understand. Actually battery is you can say just like a group of cells, more than one cell. It is actually cell but in a group, at least more than one. Okay, any battery actually it may have one or more than one cell. Okay, maybe in a series. Okay, then it is called battery. Any battery actually it may have one or more than one cell connected in series, or cell that be used as a source of electrical energy is basically a galvanic cell where the chemical energy of the redox reaction is converted into electrical energy. Batteries, many batteries are there, but battery consists of cells. More than one cell may be joined in series, and this is actually a galvanic cell where the chemical energy of the redox reaction is converted into electrical energy. However, for a battery to be of practical use, it should be reasonably lightweight, compact, and its voltage should not vary appreciably during its use. Actually, their voltage should not vary, should not change appreciably, during its use. There are mainly two types of batteries: primary batteries and secondary batteries. Then I told you it consists of cells. And what is the cells? That you know. Cells main part is anode, cathode, and suitable electrolyte. For a cell, already many times I discussed, a cell consists of anode, cathode, and electrolyte. Then here battery consists of more than one cell, may be joined in a series. Then now I am going to discuss primary batteries. It is actually two types: primary battery and secondary batteries. Batteries, you can tell many batteries are there: primary batteries and secondary batteries. And battery, I think now all are knowing. With nowadays battery has many role everywhere, and night is becoming day is due to blazing of batteries. Nowadays that everywhere where electrical current is not there, everywhere batteries they are using, in a remote area also, in hospital also, in armies they are using batteries, correct, to use their weapons, many things. Now it is they are using batteries only. Batteries are used everywhere, even in railways, in hospital, on roadside on this particularly in the night, and in car, motorcycle, in car, motorcycle, two-wheeler, everywhere batteries is going to be used. Torch is a very common, torch. Dry cell, what we are telling? Dry cell. These are common. Then now I am going to discuss primary batteries. In the primary batteries, the reaction occur only once, and after use over a period of time, battery becomes dead and cannot be reused again. The most you can say familiar or common example of this type of battery is what? Leclanche cell. Leclanche cell. What you are telling? Dry cell. This Leclanche cell, after its discovery, in the name of discoverer Leclanche, its name has been given Leclanche cell, also known as dry cell, which is used commonly in our transistors and clocks. That this battery is used. This is one that only one time it is used. After that it is thrown. It can't be reused. Okay. Then in the primary batteries, the reaction occur only once, and after use over a period of time, battery becomes dead and cannot be reused again. The most familiar example of this type is the dry cell. Dry cell, used commonly in our transistor and clocks. The cell consists of a zinc. I am telling you always, if you are talking about the batteries, it means you are talking about the cell. Talking about the cell. Then for primary battery, what is the electrode? What are the electrodes? Means anode and cathode and electrolyte. Always you should know these three things. You have to give these things. You should know what is the, we can say, electrode, what is the particularly anode and cathode and electrolyte. Always in any battery, you should understand anode, cathode and electrolyte and their reaction. Okay, these are the main things of a cell. And if cell, more than one cells, two cells, three cells, like that, if they are connected by in a series, then it is called batteries. Otherwise only cell. Okay. Then now here I am talking about in a dry cell. In dry cell or in Leclanche cell, what is the main things I am going to discuss that things. The cell consists of a, particularly for Leclanche cell I am talking about, zinc container. Okay, it consists of a dry cell, you can tell dry cell, popularly known as dry cell. Then there it consists of a zinc container that also act as anode. Means here anode is Zn. Zinc container itself function as a anode, and the cathode is a carbon. Carbon also can tell graphite rod. You might have seen any battery, if you will open it, then you will find that that white type of things you will find like aluminum. In appearance it will look like a white, like a actually Zn color you might have seen, white type of things, shining white. Then that is actually zinc container. In the middle one rod will be there, carbon rod. That also you can tell graphite. Then this function as a cathode, carbon rod or graphite function as a cathode. Then now you are knowing that in this cell Zn function as a anode, and the cathode is a carbon rod, also called graphite rod, surrounded in powdered in a, actually it will inside you will see, then it will find that carbon rod. Okay, carbon rod, that is or graphite rod, that is used as a cathode. And these things, zinc, between the zinc and carbon rod, a space is there. Their electrolytes will be there, that is filled with moist paste of ammonium chloride, NH4Cl. Between the Zn container, actually in the middle, this will be there, carbon rod, and a space is there between these two, that is filled with moist paste of ammonium chloride and zinc chloride. Mixture of both will be there. These function as a electrolyte. Then now you are understanding, anode is zinc, cathode is a carbon rod or graphite rod, and electrolyte is ammonium chloride and zinc chloride. Okay. The electrode, what are the reaction? Now you should understand what are the reaction. Then again reaction is same way of a cell reaction, you know, reaction at anode, reaction at cathode. Reaction at anode is known as half cell reaction. Reaction at cathode is also known as half cell reaction, and if you will add both, then it will be called net cell reaction. Then here same things are there. Then here at anode is the Zn. The Zn will oxidize. Zn solid, cause in the form of container solid. The Zn will oxidize and it will give Zn2 plus 2 electron. Okay, oxidation. And cathode, at cathode what will happen? Then at cathode, you know that there will be reduction. At cathode, reduction takes place. Then here what will happen, that this manganese dioxide, okay, here one more things you should know. Here in battery, if you will open, then you will see that black powder will be there. That is actually manganese dioxide. Okay, this carbon rod is surrounded by powdered manganese dioxide, MnO2. Okay, then this manganese dioxide is near the carbon rod, just surrounding the carbon rod, manganese dioxide is there in black color. Okay, then here actually this is manganese dioxide, MnO2 is surrounded by carbon. Okay, actually carbon is the distance, cathode. Carbon is cathode, and this carbon is carbon rod surrounded by the powdered manganese dioxide, and carbon mixture will be also there. Carbon powder will be also there. Manganese dioxide, powdered manganese dioxide, and carbon mixture will be there. That is surrounded. You can say near the carbon. This is surrounded. Okay. Then now at cathode, what reaction will take place? Then this actually MnO2 is helping the cathode. Cathode means carbon rod. Then at cathode, what reaction will take place? Then MnO2 cathode, this MnO2 and carbon both are functioning. This MnO2 is actually helping. It is in powdered form. Then this MnO2 plus ammonium chloride. Ammonium chloride you are taking as electrolyte. It functions as a electrolyte. then it is in the paste form. Then this manganese dioxide plus ammonium ion NH4 plus ammonium ion plus 1 plus ammonium ion plus electron, okay, because it is a reduction. Then MnO2 will take that electron, okay, and it will form MnOOH plus NH3, means ammonium ion NH4 plus now converted to ammonia gas. Then here you can see MnO2, Mn was plus 4. Now after reaction it now it became this things plus 3, okay. After taking one electron it became M plus 4, now it became plus 3, means product is MnOOH. Then OH, OH is 1 minus and oxygen is 2 minus. Then Mn both are attached to the manganese. Then oxygen will supply 2 electron, OH will supply OH 1 minus, then 3 minus is near the Mn, means 3 ion it has taken, means 3 electron Mn has accepted. Then now Mn here is Mn3 plus, that's why 3 negative charge it accepted, means 3 electron accepted, okay. Then now plus 4 became plus 3 and NH4 plus, now it converted to NH3, ammonium ion now converted to ammonia gas. Then ammonium ion came from the ammonium chloride, okay. In the reaction of cathode, here you have to see, in the reaction at cathode, manganese is reduced from the plus 4 oxidation state to plus 3 state. Ammonia produced in the reaction forms a complex with Zn. Here you have to understand, ammonia gas produced in the reaction forms a complex with Zn plus to give one complex, that is the complex is ZnNH3 whole 4 and outside 2 plus, it is forming zinc complex, okay, zinc complex ZnNH3 whole 4, okay. 4 ammonia is attached with Zn is neutral ligand, okay. Ammonia is a neutral ligand, it has no positive, no negative charge. Then here these 4 ligand have that it has this Zn has these things vacant d orbitals. Then this 4 ammonia went to that 4 vacant orbitals of Zn and it formed complex. Then Zn, that it has a plus 2 charge, that's why it forms ZnNH3 whole 4, that is the this in bracket you can write big bracket and outside 2 plus, means zinc complex, Zn complex you can tell with ammonia, okay. It forms a Zn complex. The cell has a potential of nearly 1.5 volt. This cell has a potential, it will produce 1.5 volt, okay. Then here Zn complex is forming, that is important. This I have told you about the this thing, about the dry cell or Leclanche cell. Why it is called dry cell? Then now you can understand, because in this cell no water molecule is used. no water molecule is used. Okay, no water is there. That's why it is called a dry. It is called a dry cell. Like Lancer cell is also called dry cell. And this I have told about it. It produces how much voltage? 1.5 volt. 1.5 volt. Now this internal structure, I have told you that it is made of probably three things. First Zn container will be there, and one carbon rod will be there, and around the and surrounding the carbon rod, that manganese MnO2, powdered MnO2 and carbon will be there. Okay, and there also a paste of ammonium chloride and zinc chloride will be there. Okay, then this role of zinc chloride, now you have seen that this forms complex. This forms Zn complex. Zn chloride forms complex. Okay, and this Zn complex, it will form, Zn will use the ammonia produced by Zn has been used because it forms the complex, and in that making complex, ammonia gas which is produced during the reaction at cathode it is used. Okay, it will use the ammonia gas produced at cathode, and it will form Zn complex. Then this battery, this also called dry cell, like Lancer cell or dry cell, it produces 1.5 volt. In torch you are using a battery, then two batteries you are using, each is a 1.5 volt, 1.5 volt. Okay, sometimes 4 batteries also you are using. Okay, then now this I discussed about the dry cell, and why it is called dry. I have discussed you that it here no water is used, no role of water. Now this I am going to tell about the another cell. Its name is mercury cell. Okay, mercury cell suitably for low current device. Low current, where low current is required, there this mercury cell is used. Okay, mercury cell is suitably for low energy current, like hearing aids, watches. It consists of Zn mercury amalgam as anode. Now again you should know that it anode, cathode and electrolyte. What is the anode? Here? Then anode is zinc mercury amalgam. Zinc mercury amalgam is used as anode, and a paste of HgO and carbon as the cathode. Here paste of HgO, mercuric oxide, that is used as electrolyte, and cathode is the, what is the cathode? Then carbon rod is used as cathode. Means anode is a Zn mercury anode, and cathode is carbon, and electrolyte is paste of HgO. Okay, mercuric oxide. Then what will be the reaction? Then at anode, always at anode oxidation will take place. Means Zn in the presence, one more things here, that I told you electrolytes, then a paste of HGO you are using, okay, and main things electrolytes, actually main electrolyte is KOH, actually HGO will use Zn, it will help Zn, it will help Zn, okay. This HGO main role is just to help the Zn, and electrolyte actually is potassium hydroxide and Zn, mainly potassium hydroxide is used as a electrolyte, okay. Then here you can say anode. At anode what reaction will take place? Then at anode Zn will oxidize, and it will oxidize in the presence of OH, hydroxyl ion, okay, OH minus, Zn plus 2 OH minus, it gives ZnO plus H2O plus 2 electron. This is oxidation. And cathode at cathode what will happen? And here at cathode actually HGO plus H2O will be there, okay, mercuric oxide. Here HGO and carbon, a paste of HGO and carbon is used. Then carbon I told it is used as a cathode, correct, and with Zn I told you Zn mercury amalgam, that is used as a anode. Zn Hg amalgam, that is used as anode. And cathode actually there will be carbon and this things HGO, a paste of HGO and carbon is used as cathode, and electrolyte, that is a paste of KOH and ZnO, correct. Here all things are almost in a pair. Anode Zn amalgam means you know that Zn plus Hg, that is the anode, and cathode here again in pair HGO and carbon, and electrolyte again in pair, a paste of KOH and ZnO, all are in pair 2, okay. Then here at anode Zn will oxidize in presence of OH. KOH you are using as electrolyte, that OH. The Zn plus 2 OH minus, it will give ZnO. ZnO is solid, plus H2O plus 2 electron. It forms H2O. Now this H2O and 2 electron what is produced at anode, that will be used at cathode. Then here cathode HGO and carbon I told you, a paste of both HGO and carbon. Then here at cathode HGO, cathode that is HGO. There at cathode HGO plus H2O plus 2 electron. H2O plus 2 electron, it came from anode side, that will react and it will form mercury plus 2 OH minus. It will form mercury, okay, liquid. Mercury, you know, it is in the liquid form. Then it forms Hg plus 2 OH minus, because H2O is there and with HGO O is there. Then Then now H2O became H2O. Now one more oxygen is taken. Then you can write 2OH. Why? Because 2 electron is also there. H2O is there plus oxygen. Then H2O2 you can write, but here 2 electron is there. 2 electron is there. Then it will form 2OH minus. 2OH minus. Hence reaction at cathode will be HGO plus H2O plus 2 electron. It forms mercury plus 2OH minus. Okay. Then this I told you reaction at anode, reaction at cathode, and what will be the overall reaction. Then overall reaction, just to add both. Then you have seen now at anode OH ion was there left side, and now at cathode right side OH produced. Then both 2H will be cancelled out, and electron 2 electron also will be cancelled out. Then what will remain? Zn Hg means amalgam. Zn Hg will remain, and plus HGO left side overall reaction, that is at anode Zn Hg was there at anode, that will remain, and plus HGO at cathode. Both are left side, and right side ZnO plus Hg, that is the liquid, it will remain. Okay. The cell potential is approximately 1.35 volt and remains constant during its life. It will not change. Constant voltage it will supply. It remains constant during its life, as the overall reaction does not involve any ion in solution whose concentration can change during its lifetime. Because when ion will be there, then it will change, but here no ion is there. Okay. It involves it does not involve any ion in solution. Solution is not there. Okay. All are same final reaction, nothing is there, no water is there, no ions are there. Okay. Then it remains, voltage will remain constant during its life. Why? As the overall reaction does not involve any ion in solution whose concentration can change during its lifetime. But here no solution is there, no ion is there, that's why this voltage will be constant. Okay. This I have told about the these things, mercuric cell, and this is very, very important. Okay. And in real life also it is used, and this in examination also this question is asked. Now I am going to talk about the secondary batteries. Primary batteries you have shown, I have seen. Primary batteries, now I told you, it is only one time you can use. After use you can throw it, use and throw. But now secondary battery is rechargeable battery. After the use again you can recharge. Okay. A secondary cell after use can be recharged by passing current through it in the opposite direction so that it can be used again. Means here what will happen, what discharge time, what reaction is going on, discharge time reaction is going on, correct, but charging time reaction will be reversed. Means product will become reactant. In the beginning reactants were giving product, but now charging time product will give reactants, hence the direction is changed, it becomes opposite. In opposite direction you have to charge. Now here you can see these main things I have told you. about this charging and discharging. Okay, and it charges this one more thing here. What is the main characteristic of secondary battery? A good secondary cell can undergo a large number of discharging and charging cycle. Charging and discharging cycle will be large number, many times you can charge it. Okay, and commonly used, I am talking about the very common battery, secondary battery. The most important secondary cell is the lead storage battery. Lead storage battery, which is used in nowadays everywhere in 4-wheelers, 2-wheelers, only lead storage batteries is used. And this in automobile commonly used secondary battery is this only lead storage battery. In automobile and inverters, these batteries is used. It consists of, now again you just think only three things: what is the anode, what is the cathode, what is the electrolyte. Three things you have to consider. Then here it consists of a lead anode. Lead will function as anode, and a grid of lead packed with lead dioxide as cathode. What will be the cathode? Then cathode will be you can say this lead oxide, that will be actually separately in a grid, it will be there. Okay, a grid of lead packed with lead dioxide, PbO2. It functions as a cathode. Then now you have seen lead is used as anode, lead oxide is used as a cathode, but lead oxide, it will be separate. A grid of lead packed with lead dioxide is used as cathode. Now what will be the electrolyte? Then electrolyte will be 35% solution of sulfuric acid. Sulfuric acid here 35%, not very high concentration, but 35% you can say solution of sulfuric acid is used as a electrolyte. Then now what are the reaction? This I told: anode, cathode and electrolyte. What are the reaction? Then now you can say, I am telling you, at anode what will happen? At anode, lead plus sulfate ion. From where sulfate ion will come? Then sulfate ion will come from lead sulfuric acid. H2SO4 is there. Sulfuric acid is H2SO4. Then from that gives sulfate ion, H2SO4, 2H, H plus SO4, 2 minus. Then this sulfate ion will come at anode, and here lead plus sulfate ion, it will react and it will give lead sulfate plus it will produce 2 electron. Then lead plus SO4, 2 minus. Oxidation is going on because now lead is giving 2 electron, it is releasing 2 electron. Then when lead will give 2 electron, the lead will become Pb2 plus, Pb will become Pb2 plus, then Pb2 plus SO4, 2 minus, both will react and it will form lead sulfate, PbSO4. Then this is a reaction at anode. What will happen at cathode? Reaction at cathode. Then cathode, now you can see lead oxide is cathode. Then now PbO2 plus, here also sulfate ion will be used. Here also sulfate ion will be common at anode also and at cathode also. But here this sulfate ion plus, here complete H2SO4 actually will use H2SO4, it producing hydrogen ion and sulfate ion. Hence both will be there, but in addition what will be there? That electron released at anode, that will be taken by cathode. Electron released by anode will be taken up by cathode. Means here at cathode that electron will be used, and this is the root cause for current. This electron is the root cause for current. Then this PbO2 plus H2SO4, or you can write SO4 2 minus plus 4H plus. You are talking about the H2SO4 only. H2SO4 plus 2 electron. PbO2 plus SO4 2 minus plus 4H plus 2 electron. It will also give lead sulfate. It will also give lead sulfate plus 2H2O. This is the product. Here 2H2O is forming. That is the liquid form. Water will be in the liquid form. Then overall reaction just to add both. Reaction at anode, reaction at cathode, you add it. Then what you will get? First you see here electron will be cancelled out. Both sides 2 electron is there. That will be cancelled out. Means at anode 2 electron it is releasing, and that is taken by cathode, and both electron will be cancelled out. And then what is remaining, that you write down. Then left side lead is remaining plus lead oxide is remaining, and 2SO4 is there. SO4 2 minus, again SO4 2 minus, then and 4H it is remaining. Then all together you can write 2H2SO4 because 2 sulfate ion is there and 4H ion is there. Then for 1H2SO4, for 1H2SO4 2H ion is required, but here 4H ion is there and 2 sulfate ion is there, and so you can write directly 2H2SO4. Then lead plus lead SO4, lead plus lead PbO2, lead plus lead oxide plus 2H2SO4. This is the left side, and right side that is PbSO4, that was also forming, this is also forming. At anode also lead sulfate, cathode also lead sulfate. Then PbSO4 plus PbSO4, 2 PbSO4 plus 2H2O plus 2H2O. This is the net cell reaction. Pb plus PbO2 plus 2H2SO4. Now it is giving 2 PbSO4 plus 2H2O. Then now you can see this reaction will take place when you are using, means battery is discharging, you are using, you have started to use the battery, that time this reaction will take place. But now suppose this is finishing, this battery now it is becoming low, very low, then you have to charge it, then that time reaction will take place in opposite direction, means product side. From the product side you have to pass the current, you have to charge the battery, then now you have to, direction will be opposite, means from product side, product will convert to reactant, reverse reaction will take place, means 2 PbSO4 plus 2H2O, it will give, during charging it will give Pb plus PbO2 plus 2H2SO4. Reaction is reversed during charging. Okay. Then on charging the battery, the reaction is reversed, and lead sulfate on anode and cathode is converted into lead and lead O2 respectively. What was in the beginning, again same thing will get, and it will be fully charged. Again you can use it. Okay. Then this I have discussed about the these things, lead storage battery. It is very, very useful. One more battery I want to discuss, that is this things, nickel cadmium battery, and this battery actually has a longer life than lead storage cell. Lead storage battery, it has a longer life, this, but it is costlier. Nickel cadmium cell which has longer life than the lead storage cell but more expensive to manufacture. Okay. Then here name itself is there, nickel cadmium. Nickel cadmium. Then here cadmium you will use as a anode, and cadmium will use as a anode, and nickel you will use as a cathode. Correct. Here this nickel cadmium will be used as anode, and nickel will be used as cathode, and these things here it is alkaline, means potassium hydroxide is used here. Okay, is used here, that will function as a electrolyte. Then this battery is called nickel cadmium cell, that is in a jelly form. In a jelly form it is actually arranged, and it is separated by a layer soaked in moist sodium or potassium hydroxide. That is any one is used, either sodium hydroxide or potassium hydroxide, that function as a potassium, that function as an electrolyte. Then here also cadmium will release 2 electrons. Cadmium in presence of this things KOH. Cadmium in presence of KOH, it will give cadmium hydroxide. Cadmium hydroxide means CD plus 2OH, it will give CdOH whole 2 plus 2 electron. And cathode, that is there actually nickel hydroxide, because KOH you are using, hence nickel quickly it forms nickel hydroxide, and that function as a cathode. The nickel hydroxide plus 2 electron given by anode, that will react and it will give 2 nickel hydroxide plus 2OH minus. Then see this at anode also 2OH minus was there, and in cathode as a product you are getting 2OH minus. Hence overall reaction, this 2OH minus will be cancelled out and 2 electron also will be cancelled out. At anode you know that it has produced 2 electron, that 2 electron is taken by cathode. Hence left side, right side, both electron will be cancelled out. Hence final reaction, final means overall reaction will be, that is a net cell reaction will be cadmium plus 2 nickel OH whole 2 nickel hydroxide, and it will give 2 nickel OH. Actually here I want to tell you, this at cathode nickel is forming nickel OH whole 3 plus 3, nickel is in plus 3 state, and product side when it is coming, it is becoming plus 2, because it has taken 1 electron, because 2 nickel hydroxide plus 2 electron, then each nickel has taken 1 mole electron. Then nickel was NiOH whole 3, plus 3 was there, now it became plus 2 NiOH whole 2, means each NiOH whole 2 is there, hence plus 2, plus 3 become plus 2, it means each nickel has taken 1 electron. Then overall reaction will be there. What will be overall reaction? Then cadmium plus 2 NiOH whole 2, and this is the left side, and right side 2 NiOH whole 2 plus cadmium hydroxide. Again I am telling you, left side what is remaining? CD plus 2 NiOH whole 3, CD plus 2 NiOH whole 3 trihydroxide, and product side what is remaining? Then nickel dihydroxide, you can say nickel NiOH whole 2 plus cadmium hydroxide CdOH whole 2. Okay. During charging, the above reaction is reversed. This reaction will reverse when you will charge it. Means product from reaction will start from the product side. Means product will function as a reactant, and it will give cadmium plus nickel OH whole 3. Okay, means cadmium anode, and this cadmium as anode, and nickel NiOH whole 3 as cathode. Means it will give this product. Product will become reactant, and now reactant will become product. Okay, here reaction is reversed. What was the we can say in the discharging time, use time, what is the product? Charging time, it will reverse. Means product now became reactant, and reactant became product. Okay. Then during charging, the above reaction is reversed. The open can say circuit potential of the cell range is there. It will supply 1.4 volt to 1.28 volt. Okay, and it is a compact, lightweight battery, and good cycle. This charge and discharge cycle is very long, with good cycle charge characteristic or cycle characteristics. Capacity is also good and long shelf life. Okay, it's a main application I am talking about. Application: nickel cadmium cells are used in a battery operated appliance such as pocket calculators, photo flash units, cordless garden tools, electric savers, okay, electric savers, instruments, alarm system, transmitter receivers, emergency lighting, hearing aids, telemeters. These places these are used. Again, use I am telling you. It is used, nickel cadmium cells are used in battery operated appliance such as pocket calculator. Next, photo flash units. Third, cordless garden tools. Fourth, electric savers. Fifth, many instruments, there it is used. Sixth, alarm system. Seventh, transmitter receivers, there it is used. Eighth, emergency lighting, that time it is used. And ninth, hearing aids, and 10th, telemeters. See the importance of this nickel cadmium cell. Okay, then now I am stopping only here, and next class, one more class I think it will take to finish this chapter. Okay, thank you.